Hey Trig, I'm we are beginning 2-3 and 2-4 this week. Um, Hopefully you checked your answers for 2-1 and 2-2 homework, and you'll bring that to class next time I see you face to face, okay? Any questions that you had on it? It's not graded. And we're not having a concept check this week because next week is our first exam. Our first exam is on chapters 1 and 2. You've had concept checks now on chapter 1. We're going to go through chapter 2 now without a concept check. So keep doing the homework and asking questions because that test will cover, of course, chapters 1 and 2. Okay. Anyway, chapter 2-3 is very quick. It's really just calculator work. And I think all of us in this class are pretty good. Well, when I say all of us, I mean all of you. You're better at the calculator than I am. But anyway, just understanding that we're approximating sine of different angles that aren't our 30, 60, 45, and then our quadrantal angles. We have the exact values of those. The rest of them will approximate using our calculator. Okay. When I put sine of 49 degrees, 12 minutes in my calculator, this is what I get. An approximation of that would be maybe to round off to 506, as the calculator did here. I'll tell you how many decimal places to round off to on an exam, or we're going to learn something called significant digits this today. So sometimes you just look at the least amount of significant digits in the question, and that tells you how many to put in the answer. Here we have the secant. Uh-oh. There's no secant button on my calculator, right? So people get this mixed up sometimes, okay? They'll take like the secant of 1 over 97.977 degrees instead of taking the cosine of 97.977 degrees and then taking the reciprocal of that, okay? First, you find the cosine of it, and then you find the reciprocal of that, okay? Remember, the secant of 97.977 degrees is the same as 1 over the cosine of 97.977 degrees, okay? So you can actually just put that in your calculator. You don't have to do it in 2 steps. You can put 1 divided by parenthesis cosine 97.977 degrees, end your parenthesis, and then do it that way. Okay, but for secant, cosecant, cotangent, you do have to find its reciprocal trig function of the angle, and then take the reciprocal of that. Okay, see? Don't just take 1 over the degree. All right. So, for example, here's a question. Approximate the value of 1 over the cotangent. Well, heck. 1 over the cotangent is the tangent. So all I have to do is find the tangent of 51.4283 degrees. And that's the answer. Okay? So just understand how these reciprocal functions work and how to apply them in the calculator. All right? So use a calculator to find an angle theta in the interval 0 to 90 that satisfies each condition. We want to know the sine of what angle is about this. I'm trying to find my angle, okay? This is when we use sine inverse. Sometimes people get that confused with 1 over sine. 1 over sine is cosecant. We have to actually type in 1 over sine. Sine inverse is the inverse function of sine, so it will find the angle. Okay, when I ask this question, I want to know the sine of what angle equals 0.9677. To do that, I have to undo the sine function, which is sine inverse. Okay, so hopefully, let me show you exactly how to find that on your calculator. I'll pull the calculator up. Okay, so sine inverse is right above the sine button. So if I want to know what degree gives me the sine of 0.96, I will say second sine inverse, okay? And then I'll type in the ratio 0.96770915, okay? And I get the wrong answer, it looks like. That's because I made the common mistake of not changing my mode to degrees. All right, it asked me, it said find an angle in degrees. Oopsies, my calculator was set for radians. Okay, so I have to make sure I'm in degrees. I thought maybe that was a 1 degree angle, but it's not. Okay, so sine inverse, I can hit, I don't know if you know this, but if you hit second entry, it brings up what you just, the last thing you entered, not the answer, but the last thing you entered. So sine inverse of that now in degrees is 75.3999. I'd probably say 75.4 degrees, okay? And if I want to double check it, I might say, let me make sure I did that right. That means the sine of 75.39999, 4 nines there, right? 534 is what it asked me. Is the sine of that angle 0.9677095? Yes. Okay, so you can always double check it. Now, let's look at, and I showed you that, or they were showing you that here, sine inverse, but I wasn't sure if you knew where to find it on the calculator. What if they asked me for inverse secant? Again, that's not here. I have inverse cosine, but I don't have inverse secant. Okay, so I know that the cosine is 1 over the secant, right? The cosine of theta is 1 over the secant of theta. So 1 over this, 1 over, I already have secant of theta. So this time I do have to take 1 over that number, okay? And then that'll be what the cosine of theta is. So then I take the inverse of that, okay? The cosine of theta is 1 over this. So the inverse of that will give me inverse secant. Okay, do you understand that? For inverse cosine, you would have to take, let me get rid of this. Okay, they're showing you here. I do have to take 1 over this ratio and then take the inverse cosine of that to find inverse secant. It's 18.5 degrees. Everybody okay? That's it. Fool around with this, and I give you some homework practice for this, but not a lot, because I do feel like we're pretty good with the calculator, except for these, when they're not our calculator function. So these notes are here for you to remember. Oh, which time do I just take 1 over the tangent, and which time do I actually take 1 over the thing, and then inverse? I have that here for you. Okay, the application that is used a lot with inverse cosine or inverse sine actually is right here, force of an automobile. Okay, the force in pounds is something called the grade resistance. It's the force due to gravity on a car when it goes uphill or downhill. And that's something that a trig function models. So we have force equals W sine theta. Theta is the grade, or in other words, the angle either that I'm going up or the angle from the horizontal that I'm going down. Okay, so it's the weight of the automobile. W is the weight of the automobile times the sine of theta. If the automobile is moving uphill, then theta is bigger than 0. If it's moving downhill, then theta is less than 0. So force equals weight sine theta. So there'll be a couple in your homework where I ask you to calculate force. This is a 10-pound vehicle. Or no, the force is 10 pounds. Well, that'll be a light vehicle, huh? It's a 2,500-pound car traveling uphill. It gives you all the information you need, right, to find the force. We're finding the force to the nearest 10 pounds. So when I put that in, I know force equals W sine theta, 2,500 sine of 2.5 degrees. I can do that all in my calculator. They want it to the nearest 10 pounds, so we said 110. Okay, let's see what the calculator says when we do it. Okay, just for you to see what we mean. Some people have some trouble with the rounding, and I get that. We haven't done that in a while. 2,500 sine of 2.5. Notice how it puts the parenthesis, it puts the left paren in for you. You have to remember to put the right parenthesis. I again forgot my degrees. My calculator resets to radian whenever I close out of it. So 2,500 sine of 2.5. I should have done the second entry thing. I just showed you about, but I didn't. Now we get 109. We were supposed to round to the nearest 10 pounds. It's kind of odd to do that, isn't it? Anyway, so they wanted, is it 100, 110, 120, 130? They just, let's just round to the nearest 10. So 109, they called that 110 degrees. Okay. Find the force to the nearest 10 pound for a 5,000 pound truck if it's driving downhill. So the only difference is we type in a negative angle. We actually type in the negative angle there, okay? And we get about negative 530 pounds. I just typed in 5,000 sine of negative 6.1 degrees. Do that on your calculator, see what you get. All right, make sure you can get that. F is negative because the truck is moving downhill. So if you see a negative force, you automatically know, oh, this is a car that's moving downhill. Okay? All right, think about 0 degrees and 90 degrees. If I put 0 in, okay, 0 degrees, then I get 0 pounds. If I put 90 degrees in, I get the exact weight of the car. Think about it. If theta is 0 degrees, it's level. Gravity doesn't cause a vehicle to roll at all. I'll just sit there. Makes sense, right? If I'm trying to go up a 90-degree hill, first of all, the road is vertical and the full weight of the vehicle would be pulled down by gravity. Don't go up a 90-degree hill. Okay, so the force would actually equal the weight of the car. I thought that was kind of cute little problem. All right, rule 1 of 2-4. Let's say I have this diagonal is 36 inches, okay? Or no, I'm sorry, not the diagonal. The length is 36 inches, the width is 32 inches. You know how when you get a certain size TV, it's this measure, the diagonal, okay? We want to know what size TV this is. Okay, I can measure across, I can measure down. I know it's 36 inches by 32 inches. And we want to know the diagonal. What would you use? Wouldn't you use Pythagorean theorem? Okay. But you get this weird big number, huge number. In practice, you give answers to calculations based on the least accurate number in the calculations, okay? Unless otherwise specified. Like sometimes I'll just downright say, hey, round your answer to the nearest hundredth. They would just, what would they just say, 48? They'd probably just say this is a 48-inch TV, right? Okay. If we take 32 squared plus 36 squared, see what I get, and then take the square root of that. Okay, that's where we got this big long number. That's not, you don't go to the store and ask for 48.16637, right? We would just round off probably to 48-inch TV. Okay, what we're going to learn this chapter is something called significant digits. And this is where I'll start the next video. Sometimes in college, guys, they don't say, hey, round to the nearest hundredth, round to the nearest thousandth. They just expect you to round appropriately based on the number of significant digits in the numbers in the problem. I usually tell you what to round to tell you the truth, but it's worth looking at this. Okay? I'll see you at the next video.